Hey Chem students, Ben Azmon here. Today it's time for some tender loving care for your thin layer chromatography. That's right, TLC is up today. Thin layer chromatography. Though it can be used for purification, we usually use it for determining whether or not you got your product and how pure did that product come out. We start off with a thin piece of glass or plastic when we're cheap, which we are, covered in a polar stationary phase, usually silica gel. We mark the baseline with a pencil, as well as 3 hash marks for where we're going to have our compounds. Then we're going to apply a small amount of the 2 compounds we wish to compare. In this case, I'm putting a polar compound in blue on the left and a nonpolar compound in red on the right. The middle will be dotted with both the polar and the nonpolar compound, hence red plus blue equals purple. We put the whole thing in a development jar with a mobile phase to push it up. Notice I use a squiggly line to indicate the solvent front. That's how far the solvent has traveled up the TLC plate. As we see the spots moving up the plate, you'll notice that the nonpolar is going much faster than the polar one. This is because the polar is interacting more with the stationary phase. Now I use colored dots, but a lot of times you can't see the compounds as they're moving up the TLC plate. We solve this by visualizing the TLC plate. To do this, we have different kinds of stains, UV light, powdered iodine, but once we see it, we gotta calculate the RF value. The RF value is just basically a percentage of how far up the TLC plate it went. To calculate it, we're going to take the solvent front distance. In this case, I said 7.2 centimeters. And we're also going to take the distance to your compound. In this case, I chose a red dot, let's say 5.1 centimeters. Distance to compound over distance to solvent front, we get 0.7. Notice RF values, just like percentages, do not have units. Here I am marking up one of the TLC plates. Notice I'm going to use an old school pencil. Mechanical pencils cut into the silica gel. Ink and pens are organic compounds which will run on the silica gel. So, old school pencil. Very light touch. In order to take a TLC of a compound, you need to have a dilute solution of it. So if you have a solid compound, go ahead and dissolve it. I have here a little bit of Horner Emmons product, which I'm going to dissolve in some ether. Next you need a capillary tube. Grab one of the containers and shake one of them out of the hole on the top of the cap. Dab it in your solution to suck up some of your compound, and then dot it onto your TLC plate. I'm dotting it onto the right and the middle. I do it twice just to make sure that I get enough of it on. Once again, you don't want to press in too hard or you'll cut into your silica gel and your TLC won't work. Now if you have a standard solution, you can always take a little bit of it on the tip of the pipette and just touch it to your capillary tube. This will suck in the standard solution. I'm dotting it on this time onto the left and the center. So the center has both my standard and my unknown solution. Next we consider a mobile phase. In this case I want a very non-polar mobile phase, so I'm going to take hexane. I'm going to add about 1 pipette full into my development jar. We don't want our mobile phase to be too deep, otherwise it'll be hard to develop. I can place the TLC plate into the development jar with a pair of tongs. Ideally, it will be partially submerged and standing up straight. The actual development is tough to see, so let me change the color and add some speed to this. This really takes about 5 minutes, sometimes up to 10 minutes to do. But you can definitely see the solvent front move up the TLC plate. Once the solvent front has reached the top of the TLC plate, go ahead and pull it out. You'll be able to see the solvent front for just a few more seconds, so make sure you mark it with a pencil nice and quick. I have 2 visualization methods to show you today, the first of which is shortwave ultraviolet light. It's very good at showing aromatic groups. Circle the spots you see. It's clear these aren't the same compound. Our second visualization technique is iodine, though it will work as a general visualizer for almost everything. It's very good for showing halogens. Calculate the RF for all the points that you got. Figure out which is your compound. How pure is it? Does it need further purification? If not, then you're done.